Tower Director to all units, initialize the radar grid. Welcome to the control room. If you are currently navigating the highly congested, high-pressure airspace of the Cambridge Mathematics 9709 exams, you have just tuned in to the exact frequency you need. I am your Tower Director, and today's explainer is a full-scale, examiner-focused emergency simulation. We are taking on one of the most notorious heavy aircraft in the syllabus, quadratics. But not just any quadratics. We are tracking equations that are quadratic in some function of x. You know the ones. The hidden quadratics. The ones disguised as exponentials or trigonometry that completely jam up the radar for unprepared candidates. We aren't just going to relearn basic math today. We are stepping into the elite tower to learn exactly how to manage extreme exam time pressure, prioritize high-yield marks, and safely land your grade. I am absolutely thrilled to guide you through this simulation. So, strap into your console. Activate your screens, and let's get this airspace under control.
Okay, let's dive into this and look at the scope of our incoming traffic. 15%. I need you to look at that number and let it sink in. This isn't just another minor blip on the edge of your radar screen. The concepts wrapped up in equations that are quadratic in some function of x account for roughly 15% of your total exam marks across the paper. That is a massive, heavy payload aircraft hanging right over your final grade. Think about it. 15% is often the exact fuel-to-mark budget difference between a B and an A, or an A and an A star. It is a critical sector of your mathematical airspace. If you master this specific concept, if you learn how to identify these disguised equations and route them safely to the runway, you are building a massive buffer for yourself on exam day. You are literally taking control of the skies.
Here is our flight plan for today's explainer. 1. The 15% secret. 2. Decoding the assessment objectives. 3. The deconstruct, solve, evaluate method. 4. Formatting and terminology. And 5. Top 3 examiner warnings.
Let's clear the airspace for Section 1, the 15% secret.
Every principal examiner report acts like our black box flight data, and the syllabus explicitly states this crucial line: top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. This right here is the absolute secret to managing the grid. Securing top marks requires linking your basic knowledge of quadratics with complex algebraic structures. Examiners are testing if you can spot the matrix behind the numbers. In our control room, we see two types of novice operators all the time. First, we have router Alex. Alex sees an unfamiliar context, say an equation loaded with e to the power of 2x, and immediately panics, getting completely bogged down in minor exponent rules, creating an infinite holding pattern of wasted time. Then we have router Sam. Sam spots some numbers, guesses a factorization route, and clears the argument for landing way too fast without verifying structural safety regulations. The top-performing operator doesn't do either. They recognize the hidden machinery. They see a function squared plus that same function plus a constant, and they instantly recognize the underlying quadratic flight path. That connected, adaptable understanding is what separates a crash from a flawless landing.
Moving on to Section 2, decoding the assessment objectives. To successfully route this 15% heavy aircraft, you have to understand the 3 distinct altitude levels Cambridge uses to test you. Look at this radar layout. You start at the base altitude, knowledge and understanding. This is your fundamental principles and precise definitions of quadratic behavior. But you cannot stay at this altitude. You must strategically shift your mindset and climb to application. This is where you demonstrate professional mathematical skills and deploy correct algebraic formats. It's the actual piloting of the equation. Finally, you have to reach the cruising altitude of critical analysis. This higher-order assessment objective demands that you evaluate alternatives, compare different mathematical approaches, and prove your solution works within the given constraints. This vertical progression from basic recall to tactical execution to critical evaluation is literally your roadmap to capturing every single available method mark. If you get stuck at base altitude, you fail the maneuver.
Vectoring into Section 3, the deconstruct, solve, evaluate method.
All right, operators, it's time to set up our approach vector. The heavy aircraft is on the screen. How do we bring it down safely? We use the deconstruct, solve, evaluate framework. Phase 1, deconstruct the question. Identify the given information flashing on your screen. Phase 2, break it into logical steps by selecting your analytical framework. For equations quadratic in some function of x, this is absolutely critical. Imagine you have an incoming equation with a trigonometric function squared. Router Alex would stare at it, frozen by the trigonometry, running out the clock. But an elite operator deploys a tactical substitution. You substitute a placeholder variable, let's call it u, to represent that trig function or that e to the power of x. Suddenly, the terrifying trigonometry vanishes from the radar, leaving a beautifully simple standard quadratic equation. Phase 3, you solve that simpler u quadratic systematically. Do not rush this analytical phase. Methodically declaring your substitution and solving for u is exactly where the examiner awards the bulk of your method marks. You are stabilizing the descent.
Tower transmission check. Before we clear this response for touchdown, ensure your transponder is updated, subscribe to Ace the Exams at Ace the Exams right now, and turn on all notifications so you never miss an emergency broadcast. Okay, resuming the simulation. Let's see how this builds, because finding that placeholder U is not the end of the runway. You must interpret your relationships and draw evidence-based conclusions. We encounter a massive structural block right here mid-paragraph all the time. Router Sam is notorious for this. Sam finds the values for U, cheers, and walks away from the console. But U is a phantom. You have to substitute back to find X. And step 1 of this evaluation phase is checking for reasonableness. Once you substitute back, does your X value actually make sense within the context of the original function? What if you were dealing with natural logs and your X value drops into a restricted negative domain? If you don't catch that, you violate safety regulations and the plane crashes on the tarmac. Step 2. Make justified conclusions based on those findings. Reject the invalid answers. This evaluative level is exactly what Cambridge means by higher-order analysis.
Adjusting frequency to Section 4, Formatting and Terminology.
Now, what's really interesting about this specific slide is the massive principal examiner alert attached to it. Every year, the black box data reveals that candidates consistently lose marks not because their math is wrong, but because of a total communication breakdown. Key terminology must be explicitly defined. When you introduce that placeholder variable u, you cannot just start writing u squared out of nowhere. The examiner is trying to read your radar screen. If you don't explicitly state, let u equal e to the power of x, you have created an undocumented ghost flight. If you are comparing mathematical approaches, you need to use clear comparative connectives. Identify the similarities and differences in their domain or range. Never assume the examiner knows what is in your head. Put your radio transmissions explicitly on the page.
And the communication protocols go far beyond just the initial definitions. We are talking about strict presentation conventions. These are the runway lights guiding the examiner to your final answer. Proper headings, correct mathematical terminology, appropriate formatting, and clear annotation. When you extract data from a complex text map, when you select your U substitution framework, you must execute it with crystal clear notation. Strictly applying these correct formats is precisely how you demonstrate those professional skills Cambridge is desperately looking for in the application domain. A messy, chaotic radar screen with scribbles everywhere, even if it miraculously lands on the correct final number, will bleed method marks the entire way down. Do not let a disorganized console cost you your clearance. Keep your workspace illuminated and your logic sequential.
Entering the final sector, Section 5. Top 3 Examiner Warnings.
I want to open up an interactive runway workshop for all you viewers right now. Look at your screens. Why do smart students who know their algebra, who have logged hundreds of hours of study time, consistently lose marks on this exact topic? I'll give you a massive hint. It is almost never because they forgot the quadratic formula. It's because of a breakdown in the very methodology we just mapped out. Let's do a quick sweep and reveal the top pieces of debris spotted straight from the examiner's grading floor.
Debris on the runway. Here is exactly where the safety regulations get violated. Number 1, using the wrong approach for the wrong context. This is Router Alex's signature trap. Students see a familiar exponent, panic, and try to force a logarithm before setting up the substitution, sending the equation into an unrecoverable spin. Number 2, forgetting to check format and presentation. This is radio silence, dropping annotations, skipping the critical step of substituting u back into the original function to find x, and literally leaving method marks stranded in midair. Number 3, answers are not specific to the context given. This is Router Sam's specialty. If the question asks about a real-world mathematical model and your final answer is just a raw abstract number because you failed to check for domain reasonableness in that real-world context, you will be heavily penalized. You have to clear the debris before you land. Master the method, secure the 15%. Think of this as your fuel to mark budget formula. By meticulously implementing the deconstruct, solve, evaluate methodology, by respecting the strict radio presentation conventions, and by actively sweeping your runway for those top 3 examiner warnings, you are fully empowering yourself to tackle even the most unfamiliar, heavily disguised quadratics. Router Alex and Router Sam have logged out. You are the elite operator now. You can take this framework and immediately apply it to your past paper questions today, transforming your exam anxiety into sheer absolute control of the airspace.
Which brings me to a final command for you to execute in your next operational study session. Which step of the deconstruct, solve, evaluate method will you actively practice on your next past paper? Are you going to focus on confidently executing that use substitution without getting bogged down? Are you going to focus on strictly formatting your logical steps, or will you finally remember to evaluate your answer against the domain restrictions for mathematical reasonableness? Pick one specific vector, focus on it entirely, and watch your method marks absolutely soar. Keep practicing, keep checking your radar, and stay sharp. Before you disconnect from the tower, subscribe to Ace the Exams at Ace the Exams, enable the notification bell so you never miss a briefing, and leave a comment below sharing exactly which math paper gives you the most anxiety. Tower Director signing off. I will see you in the next explainer.